lecture we are going to see the some more aspects of H.323, and one of that is its interworking with the Pstn. Then we are also going to see that what exactly are its limitations, especially when we are talking about the carrier grade telephones, and then what solutions have been proposed till now in order to overcome these limitations. So, these three aspects we will be taking up in this lecture. Now, already we have got some background about the H.323's capabilities and its functionalities. Okay. Now, right from the very beginning, means since the concept was thought of in 1995, okay, in order to 95 or 96, in order to go in for a standard like H.323, right from the very beginning, this aspect was carefully considered, that with the Pstn it should have a very proper interworking, because typically the call setup scenario could be from anything, like one can have a phone to phone. When I say phone, I am referring to the Pstn phone. So, you may have the call setup scenarios, okay, or three different call setup scenarios are possible. And these are, one is the phone to phone call setup. By phone I mean to say Pstn phone. So, it is not something that goes directly through the circuit switched network, but we are referring to that from one phone to the other, it has to ultimately make use of the IP. Okay. So, IP will be used as a backbone, or at least a part of the backbone would be the IP, but ultimately it is one Pstn phone to another Pstn phone. Okay. Then you can have an IP telephone, or what you can say as the H.323 terminal equipment, and from H.323 terminal equipment you can connect to a Pstn phone, okay, or you should be able to do the reverse of that also, that means to say phone to H.323 TE. Okay. And really speaking, there is also the fourth possibility, that H.323 TE to another H.323 TE, which is anyway taking place. In fact, when it is H.323 TE to another H.323 TE, there we are not at all involving the Pstn in any way. It is entirely within the IP, and there H.323, yes, definitely caters for that, but the interworking is not an essential requirement. And as far as the H.323 to as far as the IP connections are concerned, okay, we also have other choices. It is not that only H.323, but even the session initiation protocol, or SIP, which was developed, okay, in the 90s. Okay. One can make use of the SIP protocol also, as far as only the IP telephone to IP telephone contact is needed. Okay. But you really require a thing like H.323 whenever you are having the interworking with the Pstn. Okay. Now, typically when one has to take care of this Pstn interfacing, okay, then a gateway has to provide several functionalities. Okay. So, let us see that what are the essential ingredients that one is going to have in the gateway. So, say this is the gateway, and we are drawing a big box for the gateway, okay, because it is really going to be big, and it is this big which is going to be the problem for it. So, on one side we have the IP domain, the internet domain, and on this side we have the PSTN domain. Okay. And there should be some effective interfacing for this. Okay. Now, from the PSTN side, let us first talk about the. So, there are two different things that the gateway has to do. One is the taking care of the signaling aspects, and the other is taking care of the actual media streams or the data, okay, which will be the PCM samples in the PSTN domain and which will be the RTP payload in the internet domain. Okay. So, we should have a kind of a demarcation that part of this gateway will do the signaling job and part of the gateway would do the media stream transportation job. Okay. Now, say if we say that if we segregate the two and define a signaling plane, I mean if the top half of this we define as the signaling plane and the bottom half we define as the media plane, okay, then what are the signals that we are going to receive, okay, at the gateway? One is the ISDN Q.931. Okay. Why specifically we are calling as ISDN Q.931? Because Q.931 is also there in the H.323, but here we are specifically talking about the ISDN interfacing part of the Q.931, which should be a part of the PSTN. Okay. And because we have got all these modalities, phone to phone, 3 to 3 terminal equipment to phone or phone to 3 to 3 terminal equipment. So, that is why it can come from internet to PSTN or can go from PSTN to internet, both signaling as well as the media streams. So, that is why there should be a bidirectionality. Okay. And now, within this block we must have a PSTN signaling interface. So, this sub block that is what we are showing, it is the PSTN signaling interface. And at the and in the internet side, again at the internet end we must correspondingly have a VoIP signaling interface. And again a bidirectionality. So, in the internet the VoIP signaling has to be on the H.323 standard. Okay. So, that means to say that it has to include what? It has to include the RAS, it has to include the Q.931, the part which is supported by H.323, and for the capability negotiation it must have the H.245. Okay. So, this is needed. So, we have the PSTN end, internet end. So, when we have the supposing from an internet telephone one wants to communicate to a PSTN telephone. So, the internet telephone signaling would come through this H.323 channel. Okay. It will go to the VoIP signaling interface, but there must be a conversion that has to be done so that it is compatible with the PSTN signaling interface, because whatever signaling interface we are doing over here, okay, that signaling should be transferred at the PSTN end. So, we must have a block that does the signaling conversion, right. So, in between this PSTN signaling interface and the VoIP signaling interface, we have to have a signaling conversion block. Now, on the other side of it, okay, that is to say at the media plane side, okay, it is only dealing with the data, because the top part is dealing with the signals, the lower part will deal with the data. So, here it will be the data will be a part of the RTP payload. So, here we write as RTP, because data will be in the RTP payload, and again at the PSTN side we will be having either the encoded PCM samples that would come from the PSTN right up to this media interface which we are going to have over here, or the opposite also can happen when it is internet phone communicating to PSTN. That time the RTP payload, from the RTP payload we have to extract the data, and then that data has to be converted to the PCM samples and then should be transmitted through the PSTN interface end. So, there must be similarly the PSTN media interface on this side. So, this sub block will be the PSTN media interface. And this block we will correspondingly call as the VoIP media interface. So, very similar to what we have for the signaling, here there must be a media conversion or media transformation. So, there must be a media transformation. Okay. Which means to say that if you are receiving the PCM or rather the encoded PCM, definitely I mean from the PSTN end you will be having compressed and encoded form of the PCM samples, or whichever encoding you use, the encoded samples will be coming through the PSTN interface. Okay. And what then one has to do is to decode that. Okay. So, there must be a decoder, I mean within this media transformation there must be a decoder, and that decoder would extract the samples, and then it must have a corresponding encoder, okay, which will first encode this, because in the RTP payload what are you going to send? You have to make use of some encoding process, like the, I mean if it is speech, then G.729 or G.728, whichever standard is being followed, it has to be encoded into that. If it is video, any H.26x form of encoding has to be done, and it is this encoded bit stream which along with its headers etc. goes into the RTP payload. Okay. So, naturally there I mean two things are involved, one is the encoding part and the one is the decoding part. It is a decoding followed by encoding, and this is also referred to as what is called as media transcoding. So, transcoding is the requirement that we are having within this gateway. Okay. And just a reverse type of a transcoding will also be necessary whenever we are having the data stream coming from the internet and has to go to the PSTN, because in that case we have to extract the RTP payload, get the data, okay. We have to decode the data, because RTP payload contains again encoded form of data. So, we have to decode the RTP payload, okay, and then we have to encode it in the way this PSTN operates, okay, the form of encoding we have to do. So, again it is a decoder followed by encoder, but a different form. In that case it was the PCM to H.261 or G.728, those kind of conversion, and here it is just the opposite conversion. So, there should be a second form of transcoding that has to be there within this block. Okay. So, essentially you see that there are 6 blocks, but okay, if you are talking this as one block and this as another block, okay, that means to say one is that a gateway has got one major block which we are combinedly going to call as the Pstn interface. So, Pstn interface includes the Pstn signaling interface and Pstn media interface, and likewise there is a VoIP interface that includes this both. Okay. And then we have the signaling conversion, okay, and media transformation, signaling conversion, and we have the media transformation. Okay. And on top of it, the gateway also has to do the connection management, that is coordinating the signal flow. So, although we have not drawn that block explicitly, but that should be the hidden controller within it. So, the connection management, that also will be a part of the gateway. So, naturally it is, I mean, considering the interworking with Pstn, it is quite an involved gateway that we have to make, okay, and how that gateway has to be made. Okay. One can use hardware, one can use software. Okay. Now, the first concept, the initial concepts were that make everything within one box, go in for a monolithic solution, okay, build a gateway where you have all these things incorporated and go in for a monolithic solution of that. So, there the difficulty that one has to realize is that it is too many things that goes into one block, and let us see that which block is more involved. See, there are two distinct parts, one is the signaling part and the other is the handling of media streams. Now, if it puts, I mean, if these two combinedly puts a lot of stress on the CPU's capability, and if there is a memory limitation. So, depending upon the CPU capability and memory limitations, okay, this job would take considerable time and resource on the part of the CPU that controls this gateway, and as a result of that, the number of lines that you can handle, okay, is going to be much limited. The number of users who can simultaneously use, that gets restricted, and that may get restricted significantly as compared to the number of users whom you find in the I mean Pstn. So, as the carrier grade telephony gained experience, okay, certain limitations of H.323 was felt. Okay. So, we can list out these limitations. The first which we have been referring to is the question of scalability. So, H.323 gateways, okay, because of all this processing burden, okay, H.323 gateways can support only a few thousand lines. Whereas, the Pstn, whereas Pstn can support tens of thousands. So, naturally this is a very big issue, and if internet telephone has to compete with the Pstn, then naturally something should be done to overcome this limitation, because we should not be putting too much of burden on one single gateway by having an architecture like this single gateway. There is yet another capability that I should have talked of actually in the last class. Actually, when the signaling started, okay, the signaling protocol developments actually started with the Pstn, okay, and there, as I told you, I told you already about the Q.931, that Q.931 was a signaling standard that the Pstn community followed, but there is yet another protocol, okay, which exists in the Pstn, and that is called as the SS7, okay, the signaling system 7. So, SS7 has got certain capabilities, okay, which the Pstn can make use of, like say for example, one of the capabilities that I can mention is the direct dialing facility. You see, here when you want to dial or connect from one TE, say terminal number 1 is connected in one LAN and terminal number 2 is in a different LAN, and you have to go through the gateway. Okay, so there you have to first dial the gateway, okay, and then once you are granted, the gatekeeper grants you the permission, then as a second step you have to dial the number, okay, something like going through the exchange, and it is a two-step dialing process, no direct dialing process is there, okay, but that would have been possible had there been SS7 connectivity. So, SS7 connectivity is there in the case of the Pstn, which basically interconnects several switches through a protocol, and that is the SS7 connectivity, but there is lack of SS7 connectivity in the case of the H.323. So, I should say the lack of SS7 connectivity, and as such this SS7 connectivity cannot be inserted, okay, into this architecture, but we will see that how the modified architecture may take care of this. Then another is the reliability aspect or the availability. Now, you see that supposing in the now in the case of the H.323 or in the case of the IP telephone rather, you are seeing that all the calls are actually through the gateway. Now, what happens in case the gateway collapses, okay, in case there is a malfunction in the gateway and the gateway backs off, then what you do? And supposing it can happen in the middle of a call, okay, even if you think of having a redundant gateways, okay, you cannot switch from one gateway to the other at the middle of the call. So, naturally your call abruptly terminates because of the gateway failure. Okay. Now, there is no, I mean H.323 does not provide anything like a failover mechanism. Okay. So, H.323 does not have any failover mechanism when gateway fails in the middle of a call. So, that aspect should be taken care. And then something I was mentioning during the lack of SS7 connectivity only, that the user friendliness, many user friendliness aspects are I mean do suffer because of the non availability of SS7 connectivity, okay, due to non availability of SS7. So, naturally it is true that there has to be, and why SS7 interface cannot be built. Okay. You can ask that why do not we build that? Well, as it is, we are looking at a very burdened block, a very heavily burdened block, and if you have to cater for the SS7 interface there, okay, that makes it further more complicated. So, definitely the efforts should be to offload this gateway. Okay. Now, you see that amongst these two aspects, the signaling conversion and the media transformation, which one is going to be more computationally involved? What is your feeling? I mean, after going through the different aspects of encoding, decoding, we have seen encoder, decoder for all these. Definitely the media transformation is the most involved block, because signaling is after all what? Signaling is a set of handshakings. Okay, if you are having ideas about the handshaking at one end, then the handshaking customs at the other end also can be and handshaking customs at both the ends are known, then one can convert those handshaking protocols easily. Okay, that is not a big computational burden, but media transformation is definitely a very big computational burdens, because it is a full duplex computation that we are attempting. Okay. So, this form of a transcoding, that has to take place simultaneously from PSTN end to the internet end, and from internet end to the PSTN end, it has to simultaneously go on, and that is why there should be some architectural breakup. Okay. One should not integrate the signal and media both together, but again the question is that if we only have the media gateway, if we now split it up into a media gateway and a signaling gateway, okay, in that case is it enough? Because you may say that okay, just now I said that media media transformation takes the bulk and signaling takes small part of it. So, then wouldn't it be that the media gateway would still be congested, and the media gateway will have to take care of the bulk media stream transportation from the PSTN end to the internet end and so on, and vice versa. Well, if the media is at least separated, if the media gateway is separated, then at least one can think of an architectural solution where maybe instead of one media gateway, you can go in for a multiple media gateway, or rather to say that trying to have some sort of a decentralized solution even within the media gateway also. But of course, such a kind of a decentralization would essentially require that there must be a controller, okay, who takes the effective control of the signal gateway, and if there are more than one media gateways, then the signal control also should be then the media gateway control also should be done. So, there should be one block, okay, which would come in, okay, which should have an interconnection between the signal gateway and the media gateway, okay, and that block we will be calling as the media gateway controller. But building a hardware for the media gateway controller is not the only enough thing, okay, because now there must be a proper communication between the media gateway controller and the media gateways, which exclusively deals with the media streams at the RTP and also at the PCM domain. But actually speaking, that when this so there should be a protocol that goes into this, and this protocol is referred to as the media gateway control protocol. So, lot of new breakthroughs, okay, had to be made in order to have, in order to move away from the centralized solution of a single box gateway to a multiple box or rather a decentralized system of gateways. Okay. And that is what we are going to have. So, the functional decomposition of the gateway we should have like this. And we have the following elements. Okay. One is the signaling gateway, or SG, okay, which provides the signaling mediation between the IP and PSTN. And then one should have what I just now mentioned, the media gateway. What we can tell in short form as the MG, that provides the media mapping and or transcoding functions. Okay. The third one is the media gateway controller. Or the MGC, okay, which sits between the, so this sits between the MG, the SG and the gatekeeper, because ultimately there has to be a gatekeeper. So, and blockwise it would be something like this, that supposing we keep the signaling gateway or the SG over here. So, SG will have one link with the PSTN, okay, and then we keep an MG, and that MG will be connected to the H.323 TE. And then we have a media gateway controller MGC. So, MGC receives the PSTN signals, okay, through this SG, okay, or rather interfaces the PSTN signals through this SG, and on the IP side it interfaces. So, this is the IP side. On the IP it is linked with the gatekeeper, okay, and the media gateway is actually linked with this MGC, and this media gateway will ultimately have the PSTN interface, means for the PCM, for sending the PCM sample. So, this is the PSTN end, okay, and within this is the IP end. Now, a single mg is definitely not the kind of a solution that we are looking for, because single mg again will have lot of computational burden into it. So, what one should do is to have multiple mgs, okay. Means one mgc can control multiple mg, okay. So, if we have one mgc controlling multiple mg, then one can have a system of virtual h dot 323. So, then one can have virtual h dot 323, and in this process one can increase the line capability. Because what you are going to do essentially is that you can have with this mgc, you can have the other mgs, okay. This is one mg, this is another mg, like that, each doing its different roles, but ultimately some form of a multiplexing at the Pstn end, so that the functions of these mgs are decentralized, okay. It is only through some protocol that it will be connected to the mgc. But even now also there is a risk that what happens that when this single mgc backs off, because we have not yet addressed the reliability aspect yet, but we were talking that availability aspect or reliability is of definitely prime concern. So, in order to have the availability, one should have a kind of a redundancy that is built within it. So, there should not be one single mgc, but there should be multiple mgcs, okay. And all these mgc's status, all the call status etc., will be anyway monitored by the gatekeeper, so that when the gatekeeper so if in the middle of the call, okay, there is any failure of the mgc which is handling the call, okay, in that case, because the gatekeeper already has the information about the call history, that call setup, and I mean it knows that who is the source, who is the destination. So, that there can be a failover transfer, means immediately on detection of this fail, which the GK will be able to do, because GK is monitoring this MGC. So, it can divert from one MGC to the other, and the call can still proceed even with the failure of an MGC, the call can still take place, and this is going to be some kind of an advantage. So, in such a kind of case, what one should have is that multiple MGCs should also control each MG, okay, because if you are connected to this MG and this particular MGC fails, then the other MGC should be able to control. So, this sort of a redundancy can be built in by having multiple MGCs, and the decentralization can be achieved by having multiple MGs. Okay. So, definitely there is a bit of architectural, there is a good deal of architectural solutions, okay, which have been worked out in the recent times, okay, in order to take care of the what you say, in order to take care of the limitations that we were talking of. So, essentially we can address all these issues, and not only that, you see that what one can do is that within these MGs, okay, we can also work out the interfacing, not with the MGs, or rather because the SGs are now underburdened, okay, that we do not have a single gateway to take care of everything. So, that is why in this SGs we can build in the SS7 capability also, okay, so that whatever difficulty we had because of the lack of SS7 connectivity, okay, this also can be taken care. So, the limitations, so all the limitations that we had talked of few minutes back, that means to say the scalability. Now, we can see that the scalability can be improved by going in for multiple MGs and going in for virtual H.323 in order to increase the scalability. SS7 connectivity can now be taken care by built-in the SS7 interfacing within the SGs. Availability, yes, it can be ensured by having multiple by having multiple MGCs, okay. And the fourth point is of course the user friendliness, that yes, if the SS7 connectivity is ensured, then even one stage dialing, okay, should also be possible, okay, with the SS7 connectivity support. But as I was mentioning that this form of an architecture definitely puts a new developmental process, and which is developing a protocol so that this MGC can communicate with the SG and the MGs, okay. And that protocol is referred to as the Media Gateway Control Protocol, okay, MGCP, okay, which is the Media Gateway Control Protocol. But soon after the original development of this MGCP, okay, soon it was felt that to have these kind of capabilities like handling multiple MGCs, okay, for the sake of reliabilities, okay, and catering for the multiple gateways, okay, the original MGCP that was developed was had to be upgraded soon, and that is where the ITU and the IETF, they worked jointly, okay. The IETF and the ITU, they jointly worked and they came up with a standard which is referred to as the mega coup in the IETF parlance, and ITU refers to this as H.248. Okay. So, with the use of the mega coup or the H.248, it was seen that okay, all these limitations could be overcome. Now, that means to say that it leads to a kind of a feeling that only H.323 is not enough. Okay. We require some capability enhancements in H.323 using the H.450, what we were saying, that the H.450 should sit on top of course, you can treat H.450 as a part of H.323 already, but it should be supported, it should go hand in hand with this H.248 standard. Okay. So, together with H.323, this H.248 or mega core should take care of the capability limitations that we were talking of. But then it was also seen that so in such kind of cases, what happens is that the user terminals, the terminal endpoints are making use of H.323, whereas the media gateways and the signaling gateways, they will make use of the H.248 standard. Okay. So, both will coexist together, but it was seen that many of the terminal equipments, like say for example, the cable modems, or to say the ADSL modems. Okay. The modems also will be treated just like the way the terminal endpoints are treated, but then for these, why the calling should be done in the H.323 way. So, there is also a simultaneous thinking that whether in future one can dispense with the H.323 altogether and rather use the H.248 itself, okay, for the signaling purpose as well as for the media stream interface. Okay. So, that is one part of the development. The other area where the development process is on is with the SIP, the session initiation protocol. You see, for an IP telephone, whatever signaling is needed, everything can be done by using the SIP protocol functions. Okay. SIP also will support the same type of signaling. Okay. Only thing is that they will call, I mean in SIP parlance, they will call it by different names. Okay. But the basic protocol wise, there will be lot of similarities. Only thing is that SIP does not support the interworking with the Pstn. So, again there if one finds out a solution between the interfacing or interworking between the SIP and Pstn, then that also can pose as an alternative to H.323, because SIP happens to be a very simple protocol. In fact, in the next class we will see some aspects of the SIP protocol, and also we would like to see some of the performance parameters that comes into place with the H.323. So, H.323 is multiplexing with the several terminal equipments etc., and its performance measurements. These factors we will be seeing in the next class. Thank you.